For the last problem, I just spent a little bit of time erasing it because I started off too far over to the side, and then I ended up going this direction and kind of in my work. So I'm going to start this over, but I'm going to go ahead and move this over so that I start my initial point. In this case, it says a surveyor is locating corners of a triangular piece of property. Starting at 1/4, he walked 480 degrees in one direction at north 36 degrees west. So in every point when we do these, I want you to imagine you doing a little compass, okay? So where I have a north, south, east, and west drawn. And so if I'm going to start off and I'm going to walk north 36 degrees west, that means I'm going to start north and I'm going to come down 36 degrees. So from this one, I'm going to go ahead and draw this in. And I'm going to say that I'm going to end up being, this little part here would be 36 degrees. I actually know that I could find this one, and I'm going to in just a little bit. But imagine, remember, we're going to try and find parallel lines, and we're also going to find right triangles. So I know that this whole line is going to be then 480. So I'm going to draw it up. Now I'm going to also go ahead and draw in my little compass at this next point. Because the next point, I'm going to walk then south 21 degrees west. So that means I have to come south, but then I have to come back 21 degrees. So this little angle right here that I'm going to walk, this one will have to be then 21 degrees. And then the next corner, I'm going to finally end up going, I'm going to end up walking north 82 degrees east. And that's kind of where I messed up a little bit on my next one, because think about it, if you just to kind of get an idea, if I go north and then I go 82 east, I'm almost at that 90-degree angle here, but remember I can't do that right now because if I start off north and 82 east, I'm not going to, it would be an obtuse angle. So this angle, this actually needs to come down. And then kind of just getting an idea of how far up I'm going to end up going kind of helps me with creating my triangle. So from this point, I'm going to draw my little compass. And I'm going to imagine me walking then. Remember, I'm going to walk then north and then 82 east. And so that means I have to start off with my north and come down 82 degrees. And that will be the angle that I form then here with my for my last step. So this one's 82, but that means it's the whole thing. It's not just that little half. So maybe even bring it in front so I have 82 right here, showing that it's that entire angle. Now, keep in mind, this one will be made up of 3 different angles right here. So I can actually find out what this one is by itself, because in this case, I'm going to look for some parallel lines. And so on this one, if I imagine this one is a parallel line and this is a parallel line right here for my other one, and this is the line that's cut by a transversal. So if I draw it out to the side, I don't know if that would help, but this is this line. Then I'm going to go to my other compass line, which is up here, and then I'm going to be cut by the transversal. Well, I know that the one that's cut by the transversal is 21 degrees. But the other one on this side, these would be alternate interior angles, and this one's also 21. And that would be the one that would correspond right here, this little angle between. And that allows me to get my angle of my triangle. So my angle of my triangle then would be then 82 minus 21, or 61 degrees. And 61 then would be just from the angle of my triangle. Now I need to find out at this point, I have the amount 480, and I also have, in this case, I've got one angle. I need to kind of find out something more on this in order for me to go ahead and apply one of my properties for the area. So in other words, if I can go ahead and find another angle, that would sure be helpful. So I know that I can get this one because this creates a right angle with my north, south, east, and west. So in this case, it would be the complementary of 36. So 90 minus 36 would be then 54. So I know this one is 54 degrees. And in order for me to get to another one, I'm going to have to figure out another little part. I'm going to have to use my parallel lines, I believe. So I know that I have this one. I could use, here's my transversal here. What if I had this one as a transversal? So if I had this line, and this line, if it was cut by a transversal, okay, so I think I got it. So this line and this line, okay, imagine these two lines as parallel, and then I'm going to cut this one as my transversal. So I'm going to kind of go at the same angle. So I know that this one was my 82 degrees, and that would mean that this other one here that one's 82. And that would be 90 and 90. So these have to add up to then 180 degrees. So because I have 36, I also have the 54, I have 82, and I have this little tiny angle right here. And so those all have to be 180 degrees. And that would indicate then I could go ahead and do 54 plus 36. Oh, sorry, that was 90. That was dumb. Plus then 82, and then I've subtract that from the 180. Good grief. 180 minus the 172 should be 8 degrees. Then the total between 54 and 8 would give me my angle. So my angle then would be this one, which would be 54 plus 8, or 62. Now, the next one, remember on my my formula, I have to go ahead and I'd have to have another angle. So I would have to have like two sides and an angle in order to use my first one, or I have to know all of my sides. But I know that I can get that with the law of sine or cosines. So in this case, what I'm going to do, let's go ahead and finish out my triangle. I know that if I have 62 and 61, 62 plus 61 is going to be 123 minus the 180. This gives me the angle of 57. So at this point, I could go ahead and try maybe the law of sines. I could, because I know that I have then the sine of 480 divided by the sine of 61 would equal then the sine, my x over the sine of 57. And so by solving for x, then I would take then sine of 57 times 480 divided by the sine of 61. Whoops. So, whoops, I had the sine of 57 equals times 480 and then divided by the sine of 61. Try that again. I had 460. At this point, I can go ahead and use, since I have the two sides, I can go ahead and use my formula. A equals 1/2 times 480 times 460, and then probably got to do 0.27 times the sine of 62, and that will take care of me. So I have 460 times 480 divided by 2, take it times 1/2, and then take it times then the sine of 62. So my area then would equal 97,534.79. Oh, to the nearest tenth, make that 8. And it will be feet squared. I'll let you take a quick picture and pause that.